Hello. It's great to be here. I hope we're all having a great time. My name is Maryam. I am a product developer with Morphologic UK. And I would be talking today about building fast with AI, of course, without losing control. But before I get into anything, I want to take a quick survey. It's going to be a couple of questions. And if it applies to you, you would let me know by a very quick hands up. Remember, be honest, nobody's judging. The first question is, has anybody today used an AI tool to do something? It could be to write a block of code or to respond to an email or even respond to an argument. Hands up. So that's a lot of us. Great. Question 2. Has anyone here this week used AI to generate a block or blocks of code? Took a look at it, doesn't really understand what it does, but accepts it anyway. Good. Same with me. And the last question. Has anyone here looked back at the code that they've written, whether they wrote it themselves or they wrote it with AI? They've written it some times back and checked again recently, took a look at it and wonder, what was I trying to do here, or what exactly is this code trying to do? Again, not judging, we can be honest with ourselves. I have thought all three myself as well. Hands up. Great. So we already know what it is we're talking about today. You see, that feeling of opening a legacy code and not understanding what it does is the same feeling we would get from our code bases in a couple of years if we are not careful. A lot of us, maybe 90% of us, now use AI coding tools every day. Be it Claude Code or Gemini or Codex, whatever tool you use. And the more we use these tools, the more we see how good these tools are, and then the more we are tempted to accept whatever code these tools generate without checking or understanding what the code does. So the question has moved from, should we use AI tools to write codes? That ship has sailed. The question is now, how do we use AI coding tools to write codes that are efficient and won't break in the future? AI is now part of our workflow. We are living through what I believe is the biggest productivity shift software engineering has ever seen. Features that would usually take an entire weekend can now be built in hours. Prototypes that would take you an entire week can be built in a day or two. You can even build an entire application from start to finish in just 8 hours. And it is exciting, yes. But there could be a tiny bit of a problem if you are not careful about the way we go with it. Because the truth is, artificial intelligence tools might make writing code fast and cheap, but it doesn't make understanding the code that's written cheap or fast, or maintaining that code. It doesn't make it cheap or fast, or even owning the code when a break happens cheap or fast. So the problem has shifted from writing code to having a good judgment. The decision that you take with your AI generated codes, it will separate you from someone who just writes fast using AI and deploys, from someone who really knows what is going on with their code. A quick background on why this topic is important. Sometimes last year, a friend of mine reached out to me to fix a bug in his app. It was an internal app, it was built with AI, built fast by the way. According to him, he built and deployed it in just days. And at first, it was impressive. The design was great, the features were working, everybody was happy, until it decided to integrate a third party tool into that app, and everything came crashing down. So I went into the code base and I started to see the cracks. And I should note that this was a time when I genuinely detested the idea of vibe coding. So you should know what dilemma I was in, but I couldn't say no. I had to help. Looking into the code base, there were so many flaws. When he needed the same thing in two different places, rather than the AI to reuse the code it's already written, he wrote it all over again. So we had duplicated codes. So rather than fix a bug in one place, we had to fix it in 10 different places. The AI tool also hallucinated a lot of features that nobody asked for. It installed and imported packages that were never used. It had variables and functions that were never used in any part of the code. It's like for every new request or every new prompt that he had to add something or update something, it keeps adding more code and more files rather than you reusing existing functions or existing variables. And none of that broke anything, because technically it is doing what it is supposed to do. But unfortunately, the code base had become a maze, which was quite an annoying experience. And the more I looked at AI generated code bases, the more I realized that this is happening more often than we give it credit for. Yes, we are all building with AI now. New developers, experienced developers, entire companies are mandating the use of AI to write codes to save time and to save money. On the surface, it's working. We're shipping things fast. We're rounding up projects really fast. But underneath, we're starting to have code bases that nobody fully understands. We're having logic that's so tangled that even the person that built it might not be able to trace what went wrong. It's starting to feel like we've started accepting AI generated code the same way we accept terms and conditions. I don't read terms and conditions. I just scroll through very fast and I accept it, fingers crossed, and hope for the best. In simple terms, we're starting to lose developer integrity when we ship software. And here is the thing. This is not an AI problem, because AI did exactly what it was asked to do, the way it understands how to do it. It generated plausible, working code from its prompts. Code that works, code that shipped, code that worked most of the time. But the failure of that app was the gap. The gap between, yes, this code works, and yes, I understand why this code works. And the day that the environment changed, the day that a third party was introduced into the equation, that gap turned into a black box that nobody could easily navigate or understand. So one takeaway from this is that vibe coding can get you to working, but it cannot get you to owning. And the difference only ever shows up when something changes or when something breaks. Another friend of mine detests the word vibe coding, and we coined the term strategic development. So just in case I use that interchangeably during the course of this talk. So today I'm going to be sharing practical steps that I have used and people that I know have used while using artificial intelligence to write codes that are efficient, codes to write codes fast, and at the same time, codes that won't break. So we rebuilt this project, maybe not entirely from scratch, but we rebuilt it over a period of time. We did not just rebuild this project, we also built a second app, same conditions, we used the same tools, and we got different outcomes. We built them fast, we built them with AI assistants. We deployed them pretty quickly. It did take a little longer than the first version of the app did, but it came out better. It was more sustainable in a way. Whenever we made a change or we made an update or we integrated a third-party service into it, it did not turn into chaos. So using the same approach, but we got different results. So what did we do differently? And to be honest, the answer is quite simple. It actually comes down to an handful of habits. Step 1, when you're using AI, follow the junior dev rule. Treat your AI tool as a junior developer. This is more of a mindset shift. AI is a tool, yes. It is a powerful tool, and it is the fastest, most confident junior developer as well. Like every other junior developer, or maybe just a new developer on your team, you would not just merge their PR without reading them, would you? No. And it's not because they write bad code. No, they could be genuinely valuable. It's not because they could have made a mistake while writing the code. No, but it's because they're new to the team and they're yet to learn your methods, the way you name your variables, the name you write your functions, the way you consume APIs or third-party services. They are yet to learn how your system works. So you have to review everything that they write. Again, not because they're bad, but because that coding structure matters. And also because confidence and correctness are not the same thing. Artificial intelligence is very confident. In fact, it is the most confident developer you will ever work with. It will tell you 1 + 1 is 2 with the same confidence that it tells you 5 + 5 is 55. It will use the same exact tone, whether it's completely correct or completely wrong. It could literally tell you it's raining outside right now when it's sunny. That's just the way it is built. Plus, I was once a junior developer. I remember the excitement of working on a live project. I remember how I was so excited about having my code on live, and I ended up overwriting and overbuilding. Rather than go from A to B, I did A to J and then went back to B. So reflecting on that, it's quite easy for this AI tool to overbuild. So consider them a junior developer. You can ask for a simple method and then it would use or even write 3 other methods to arrive at that method, overbuilding. So put it simply, artificial intelligence coding tools can tell you how to build anything, any feature that you describe. It cannot tell you whether that feature should exist. You need to make that judgment yourself. So it's most times not a coding question, but a product question. You know your customer. You know how to get there. So rather than let the AI guide you, you guide the AI. Step 2, identify your load-bearing codes. What are your load-bearing codes? These are the parts of your system that when something goes off with them, your entire system becomes useless. It could be your authentication system or your main logic that fits your entire system, or the data structure. These are areas that you should understand deeply, no matter who wrote them, AI or human. Everything else after this, you can let AI handle them without interrogating every single line. The skill here is that you don't review everything. It's knowing the parts that hold the most weight, going deep in there, and before accepting any change from either human or an AI tool, you understand every step and every method that's been used. Let's use an example. Say you prompt your Claude code to build you, say, an event management platform, and within minutes, it can generate your authentication APIs, your database models, your email notifications, even your dashboards. Everything works. But it still doesn't answer some important questions. Questions like, what happens when you have so many events? What happens when 1 million people use your platform at the same time? What about privacy? What about compliance? Questions like what the business goals are. Questions like who has access to what? So the answers to these questions are what your load-bearing codes are. What if something breaks? If any of these things breaks, or the conditions for any of these things changes, would your system, would your app be able to survive? These are your duties. These are not AIs. You draw the boundaries and then you let the AI fill in the other systems that you don't have to worry about. Do you want to risk data being lost, or do you want to risk your users trying to use your system and not being able to access it? Then you lose them. Do you want to risk all that? Those are questions that you need to ask yourselves. And the answers to these questions would help you identify what those critical parts of your product or your app or your software is. It is now up to you to pay close attention to this load-bearing code. Guide whatever tool you're using to get the best results, rather than being at the mercy of that tool. You own the products. You should be in charge. Another important step is write your specs before you prompt. I know, the idea of using artificial intelligence tools to write your codes is to save time. So why do you need to spend more time writing your specifications when you can write the prompts and that tool can figure out what the specification is and give you the generated code? But like I say, you have to pick your delay. 1 page, it's enough. What am I building? What must not break? What does dawn look like? It might sound like the opposite of moving fast, but like I said, the math is simple. Writing that spec now can take you maybe an hour maximum, but rebuilding a maze could take you days. So you have to pick your slow. And the good thing is, AI tools can also write the specs for you. You could have a quick chat with Claude Code. I keep saying Claude Code, but I meant any AI tool out there that helps you code. You could have a quick chat with it, and it could create this spec document for you. And what that does is it lets AI understand what pattern to follow. Because when there is no pattern to follow, the artificial intelligence tool invents everything every time. So when you give it a structure, it builds within that structure. Next method, and this would be the most important of all the points I have mentioned today, tests what AI assumes. One thing you should know is that AI is very optimistic. It builds for the happy parts. It also tests for the happy parts. It builds in such a way that the user does exactly the right thing and the network do not blink. It's expecting an integer, so it gives it an integer. That's what AI does. The edge cases are your job to find. What would happen if the API times out? What would happen if somebody submits an empty form? What would happen if instead of characters, alphabets, the user gives numbers? And I know the front end, we do a lot of validation. But what if I submitted my request via Postman? These questions, these test cases, they are yours to find and yours to test. The good thing is, AI can also help you create these test cases. You can simply have a conversation about it. You would find what they are, but you still have to test them yourselves. The AI would not write these tests unless you ask. And the thing is, even when you ask for it, you still have to check to see that the test actually works or it actually tested something. Because it's easy, like I said, that confidence developer, it's quite easy for it to say, yes, I've run through these 10 test cases and they all came back positive. Because what it would do is, it would easily, happily write you a test that would mock what you're meant to be testing. And then it checks against the same mock test that it has written and then gives you back a mock result. It would say it's positive. It's a passed test when it actually did not run the test. So you need to give it that rule. Your AI tool can write 40, 50, maybe 200 tests. And these test cases has to be around your rule. AI can't invent that rule. You have to do that yourself. It could even do everything the right way, but make a very, very small mistake. I was a victim to this a couple of days ago, where I asked it to write a quick function to retrieve some data for me. I tested and it worked. I really did not look at the generated code. But a couple of days ago, we realized that some of the data were not complete. And that's because rather than it to use values, it used value. Both exist in the database. So he was returning data, but he was returning the wrong data, which is a very good example of the fact that speed and understanding what is written, they're not quite opposite. You don't have to go deep into everything. You just have to be intentional about what part you have to go deep into and what you need to confirm. So for whatever it is you're building, for it not to fall apart, we need to take a step back from accepting every AI generated code and determine where AI judgment ends and our own judgment has to begin. In simple terms, draw the line. AI is very, very brilliant when the cost of being wrong is low. You need to set up a boilerplate. You need to refactor a block of code. You need to get the first draft of your tests. You need to poke around a new library or a new package. You need to make a quick decision or a quick research about what library to use or what package to use. Or you need to quickly figure out an algorithm. All these things, they have low costs. If something happens along the way, there is no big repercussion. So you can give this your AI tools completely. They help you make the research, but the final decisions lie with you. All of these steps or these methods fall under a framework, being responsible by default. You need to understand what you're shaping. You can use AI to scaffold, but you own the structure. You do need to know where the walls are because those are the ones you can't move blindly later. You need to review at all times. Do not blind trust. It's supposed to be a human in the loop process, not just a human accepting the code that AI has generated. You need to identify any gaps. You need to identify these gaps because future bugs would live in these gaps. You also need to identify your unknown. Say you're in a hurry, you're pressed for time, and you can't really investigate what this block of code is doing. Flag it for later. Don't ignore it just because it works. You need to test what AI assumes. This is very, very important. The optimistic nature of AI coding tools would not let you fully test edge cases. So these edge cases are yours to test. The timeouts, the empty inputs, 2 users at once, 1 million users trying to access the same tool or the same resource at the same time. What happens in these cases? These are your tests to write. This is your job to make sure that these things, when they really happen on production, you have or your product continues to work rather than it break and your users get disappointed. And finally, you need to ship with a map. Just because you're building really, really fast doesn't mean you have to deploy everything at once. As you're developing, as you're making changes, document what you built and why. Even if it's 2 lines, why did you do it this way? Why did document that? Well, it doesn't have to be within your code base. Just have it somewhere. You're not writing paragraphs. You're just writing 2 sentences. Notes the reason, notes the architecture. Whatever option, whatever decision that you take, why did you take that decision? You can note those as well because those would serve as reminders in the future when you need to update that block of code. And to be honest, all of this might seem like it's not going as fast as it should be. But what's the point of going fast when your tool or your products become useless in the future? Just like Jack said earlier, software development is evolving, and it is evolving really fast. We have to evolve with it as well. Whether you see yourself as a vibe coder or you are, like myself and my friends, a strategic developer, people use your tool, whatever tool you build, whatever product you build, whatever app you build, people use them every day. So you need to be responsible for that security that they are supposed to get when they use your product. At the same time, whichever tool you use, you should be ready to use them, whatever tool is available, so that you move as fast as the work allows you and you ship things you actually understand. Not because you're slow, but because you're good. Because honestly, you're only as good as the tool you use is only as good as you are. Move fast, yes, but move efficiently as well. Only ship things that you actually understand. Because the developers, the engineers that will thrive and survive, they're not just the ones who prompt the fastest or the ones who decide not to prompt at all. With every advancement that comes after this, the developers that thrive are the ones that know what they're building, why it is structured the way it is, what to do when something breaks, and the ones that use every tool available to make their jobs easier for them. So we need to embrace a responsible framework. We need to build like our users accounting on us, because literally they are by using our systems. We need to understand that we're not just going to be janitors that would clean up AI generated codes when things break. And we don't have to be pure fivers as well, just accepting every code that AI generates for us. Instead, again, we should be people who use every tool available to move as fast as that work allows and deploy things that we truly understand. Because the people that are on the other end of the software that we build, they don't know how it's built. They don't care how it's built. They just like or live for what it does. So being responsible by default is not about slowing down. It's about knowing what you're shipping before somebody else finds out for you. Thank you.